Chemistry, Chapter 10, Section 2, Liquids. The objectives of this section is to describe the properties of liquids according to the kinetic-molecular theory, to define and discuss vaporization, to define and discuss freezing, the properties of liquids according to the kinetic-molecular theory. As we mentioned before, that gases, the particles of gases are far away from each other, so the gas particles fill the container. In liquids, the particles are closer to each other, so the liquid just takes the shape of the container without filling the whole container. While in the case of a solid, the solids have definite shape and definite volume. So a liquid has a definite volume and takes the shape of its container. The attractive force between particles in a liquid are more effective or more stronger than those in a gas. And the attraction between liquid particles is caused by the intermolecular forces among the particles of the liquid. Why the particles of a liquid are not bound in fixed positions and they move past each other freely due to the weaker intermolecular forces. There are intermolecular forces, but they are weak intermolecular forces. So the particles of a liquid move past each other freely. Fluid is a substance that has no definite shape and can't flow. Examples: liquids and gases. So liquids and gases are fluids because they don't have a definite shape and they can't flow. Another property of liquids that liquids have relatively high density and their densities are larger than that of gases. Why? As you can see from the figure that the particles of a gas are far away from each other and the particles of a liquid are closely packed together. So the density of a liquid is much higher than the density of a gas. And the density of liquids are hundreds of times denser than gases due to the particles are closely packed together. Another property of liquids that is different from gases, that liquids have relative incompressibility. They are not compressed. As you can see also, liquids are much less compressible than gases. This can be explained because the particles of a liquid are closely packed together than the particles of a gas. The particles of a gas can be compressed because there are larger intermolecular spaces among them, so they can be compressed, while the particles of a liquid are incompressible. Another property of liquids, which is diffusion, and diffusion means mixing together, as in the case of gases, which can diffuse with each other. Liquids also can diffuse if the two liquids can mix with each other. So here is food coloring or a dye is dropped into a cup of water. The dye starts to spread throughout the water. You're starting, and here the dye starts to spread more, and here the dye forms a solution with water. As you can see, the particles of water before adding the dye. After the dye is mixed somehow with the water, here the particles of the dye and the particles of water. When the dye forms a solution, here homogeneous solution is formed between the particles of the dye and the particles of water. So liquids can diffuse with each other. So liquids have the ability to diffuse. Any liquid gradually diffuses throughout any other liquid in which it can dissolve. Some liquids do not dissolve with each other, like oil and water. Why? Why liquids have the ability to diffuse? Due to the constant random motion of the particles of the liquid that cause diffusion in liquids. The constant random motion of the particles. As the particles of liquids can move past each other freely. But diffusion in liquids is much slower than that in gases. Why? Because the attraction force among the particles of liquids slow their movement. They move slowly than the particles of a gas, so the diffusion is much slower than that in gases. What are the factors that affect the diffusion rate of liquids? Here is the temperature. As the temperature of liquids increases, their diffusion rate increases. They can dissolve faster. The higher the temperature, the faster the diffusion rate. Another property of liquids, which is surface tension. As you can see here, this is an insect. Then insect can move on a surface of water without being seen. Without sinking, it can move on the surface of water. What causes this phenomenon? This is caused by surface tension. This can be explained by the fact that the particles inside the liquid is attracted from all directions by all molecules around it. But a particle or a molecule on the surface is attracted from the sides, from down, and not from above. So this attraction force causes the surface of the liquid or water to be as a stretched thin membrane or elastic thin membrane that can carry the insect here. So the molecules at the surface like this one, can form hydrogen bonds with other molecules around it, but not with the air molecules above it. So surface tension, a force that tends to pull adjacent parts of the liquid surface together. This causes the adjacent part of the surface of the liquid to be in attraction force. Surface tension decreases the surface area to the smallest possible size, as in the case of raindrops. Rain droplets are spherical. Why they are spherical? Because the surface tension causes the water drop to decrease its size to the possible, which is the surface of the sphere. The higher the force of attraction among the particles of the liquid, the higher the surface tension. It's logic. Another property is the capillary action. As you can see in the figure, here narrow tubes are placed in a liquid. The liquid starts to rise up inside the tubes. But the narrower the tube, the higher the level of the water, the height of water inside the tube. Here, wider tube, water rises less, while here, narrow tube, the water rises more. This is capillary action. It's caused by the attraction of the liquid particles to the surface of a solid. Here, the walls of the tube and the liquid are attracted to each other, so the water starts to rise up. This attraction tends to pull the liquid upwards against the pull of gravity. So a liquid will rise in narrow tube due to the attraction force, which is called capillary action. Another property related to the attraction force between the particles of a liquid and a solid is the curved surface of liquid, as you can see here in water, and also the curved surface of mercury with glass. Evaporation and boiling. What's meant by evaporation and boiling and the difference between them? Let's start with the vaporization, the process by which a liquid or a solid is changed into a gas. We will be discussed in detail in section 4. While evaporation is considered a part of vaporization, the process by which the particles of a liquid escape from the surface of a non-boiling liquid and enter the gas state. What's meant by non-boiling liquid means below the boiling point of that liquid. For example, water boils at 100 degrees Celsius. If the temperature of water is 50 or 40, some water molecules escape from the surface of water, like what happens in the sea. Water evaporates from the surface of water to form clouds. So, below the boiling point, liquids can evaporate, can change to gas state, which is evaporation. Evaporation occurs because the particles of liquids have different kinetic energies. Some particles have lower kinetic energy and other particles have higher kinetic energies. the particles with higher kinetic energies, with higher speeds, can escape from the surface of the liquid and form gas. While boiling is the change of a liquid to bubbles of vapor that appear throughout the liquid. Here, if the liquid is heated to the boiling point, it starts to form bubbles of vapor that change to the liquid state. So, boiling means at the boiling point, when the vapor pressure equals the atmospheric pressure. Liquids can change into a gas, like the changing of water to ice. So, when a liquid is cooled, the average kinetic energy of the particle decreases, causes the liquid to change into a solid. And this is called freezing or solidification. It is a physical change of a liquid to a solid by removal of energy as heat. If you put a cup of water in the freezer, heat is removed from the cup of water. So the energy decreases and it changes into the solid state, which is called freezing or solidification.